Alright, so let's get started. So last time we kind of created a print GameState function. Well, technically, it only prints the coins. Like, there's still some information in GameState that's not captured, like whose turn it is, and you know, the obstacles. But the obstacles are static; they never change, so that doesn't really matter. And then also there are no wins in this for this bot stuff. So it's just like the most crucial features are really the coins themselves. Also, like I mentioned, it kind of it's just like a debugging function. So I don't really it's not like we care about the standards that I have for it are less strict. Like, they're just whatever. Status. Okay. Get log. Yeah, so last time we just kind of created the helper function, print coins discretized, and we're doing some work on Scratchpad. So let's just kind of open up a Scratchpad. And then what we did is so we have a game state, and then we have like a move 1. So like we move it 45 degrees. So that means northeast, right? And then move velocity, we just kind of like get it from the move ID itself. Then we take the first coin, and then we kind of like build a move. And then we just, okay, let me just like draw it out, right? So then like whiteboard. So, okay, first of all, like we have like kind of like 3 coins here and 3 coins there, right? Like this. So then we're going to take this coin and we're going to launch it there. So this is GS, right? And then after the launch, what's happening is we get GS next. So like again, 3 coins here, nothing has changed. Maybe that's a bit exaggerated, but like this. So this coin basically kind of moves here, right? And now let's also say P1 turn for P1 turn. And now it is P2's turn. P2 turn. And now P2 turn. What should P2 do? You know, like there's like 2 main approaches. One is kind of move directly and mirror it, or kind of like move the other direction and do some sort of like a dance, like kind of reminds me of the horizontal and vertical flipped, right? Kind of like that. Right, so we could just kind of like break the symmetry and like have the king move here, maybe. So what I want to do, so this is GS next. Now GS next, this game state next, has a back pointer to GS, and GS has a back pointer to null or undefined, right? Just to nothing, right? Because it's the very like start, right? So then one thing I want to do when like doing symmetry is like, yes, we could kind of call symmetry on GS next and like kind of print that out. But one thing I want to do is kind of like execute this move so that we have like, let's call this like GS next or something, right? So I want to kind of create one more move and call this GS next. I could like GS1, GS2, GS3, or 0, 1, 2, but whatever. Next. It's not a big deal. We have very limited game states. And then my idea is like, I want to kind of like call the symmetry test. I want to test the symmetry on GS next. So like, I want to like kind of see GS next like being mirrored in different ways, or flipped, transformed in different ways. So let's first kind of copy and then P1 turn. And we're omitting the obstacles. Oh wait, no. Let me actually... This should actually be like, they shouldn't be on the same line. This one should be a bit higher. Kind of like that. And something like this, right? GS next. So what we want to do is we're gonna like test symmetries on GS next, right? So let's just do it. Let's create GS next. Put some spaces, or actually no, wait a minute. So make a substitute. Make the move one ID, move one ID, move one ID, and that's it, right? And now let's kind of like create a move two ID. Is what direction? So like 0, 1, 2, 3, 4. Yeah, pi, 4. It's number of zeros divided by 2, right? Is 4. Or 4, that means we're going directly to the west, right? So let the move equal to move of which coin? Well, first of all, move 2 ID. That's the first thing. Oh, move velocity, sorry. We have to first get the move velocity. Oh wait, no, move 1 velocity. So the ID, then we get the velocities. And then we have to kind of make these two. Two ID, and then now the question is which coins we do. So I think it's like 0, 1, 2, 3, 4. Right? I think it's 4. And let's make this move 1. Like that. It's a similar thing except like next is next.clone, and then just next that apply move of move 2, and now the back pointer will be at what we just cloned, like that, right? Now we want to test symmetries on GS next. Want to test symmetries on GS next. We'll start off with the state symmetries, transform game state, and then we'll do some transform policies, right? So we have to we're gonna have to also assign a policy to GS next as well, right? But let's first do just game state. In fact, that might just be all I do this stream. So we want to test symmetries. Start with transform Form game state particularly testing a historical transform as well for prev.js. So let's just like look at GameState.ts to make sure like that which coin, what are the coins? C1, C2, C3. So it's 0, 1. Like I said that like we're taking like the fourth coin, 0, 1, 2, 3, 4. But let me just verify that. So we have C1, C2, C3, right? And then at the end we're taking P1 coins, we're concatenating P2 coins. And these are just the mirrored coins. So then we're the coin we want to launch is the mirror of C2. So you have C1, C2, C3, mirror C1, mirror C2, mirror C3. And so then what we want is mirror C2, and that's second to last, with a C3, mirror C3 being last. So yeah, that checks out. Like the last index is 5, since it's 0 to 5. 6 coins, index 0 to 5. Second to last is 4, right? Just the consequence of 0-based indexing. So yeah, 4. That is correct. Like, sorry about this, 26, like this line here, right? When we have like GS coins of 4, I just kind of opened up that file to like verify that 4 is correct. Like coins gives us P2 king. Oh, there's no need for that comment. Just a scratch pad after all. So symmetries on GS next. Okay. Actually, one thing I want to do first is let's still print out GS next. So let's make that, instead of next, let's make it a next. So this should kind of give us like, this should print out GS next, and this should print out just GS next, because we're kind of going prev, right? Just kind of like that. And for good measure, let's just take this, and let's just add another one at that, just to go to original, right? So we're kind of like, if this is like 1, 2, and 3, then like we're gonna print out 3, then 2, then 1, kind of like that, because of these kind of prev back pointers that should be set correctly. So let's just kind of print out basically all 3 of these screens, right? Let's just kind of see what the result is from doing that. Compile it. Okay. Let's open line 28. Oh yes, I have to call this move 2. Does this look good? Let's just refresh. Like GS, move 1 ID, move 1 velocity, move 1. GS next. Move 2 ID, move 2 velocity, move 2. So like these 3, like that, like move 2 ID, move 2 velocity, move 2. Same as move 1 ID, move 1 velocity, move 1. So they kind of match. And then what we do once we have the move is we simply do a clone and then apply the move 2. So yeah, that looks like everything's in order. So let's was a source map flag? I think I want to just like do that too. What's that? Which I did there. Just so that I can like compile it, the source maps for my whatever I do in VS Code too, just for debugging support. So okay, so we have that. Now let's just kind of do the on it. Should not see this message. It is not this player's turn yet. Okay, we found the bug, so that's kind of nice. It is not this player's turn yet. Okay, so here's the error. Okay, well, let's open up Visual Studio Code. Okay, this is being stupid. Okay, so we got ourselves a scratch pad. So this is the bug. GS next is P1 turn is true, but the next game state is P2's turn, right? Like, let's just delete or close that. Yes, so this is P1's turn, but this is P2's turn, right? We're trying to launch P2's coin. But why? Let's kind of go into apply move. So that's the bug. We have to change the turn, right? Let's look at what connect 4 does. Connect 4 GameState CF.TS. And apply move. Where's apply move? Yeah, see this? We need to copy this line to swap the turns, right? Wait, why did I not have that? Why is this line missing? Well, whatever. Copy that line. We have a is P1 turn field, so that's fine. We can just kind of apply it. Now, the moment we kind of finish that, like right before we return, we kind of have to do that. Just like that. Save that. Okay, so now now this looks good, right? This looks good. Let's compile it again. And then let's just what am I doing? Debugging it. I mean, running it again. Oh, we have it paused. Oops. Let's just break out of that. Yeah, we saw the problem. Let's just compile it again for good measure. Okay, we got it compiled. Actually, one thing I want to do is like kind of keep everything consistent. Like whatever this command for compiling was, just copy this thing here to kind of just copy that. So everything uses the same command to compile. What is this? Okay, so now we have it compiled. Let's just do it one more time for good measure. And now let's debug. So now GS next, is P1 turn is false, and then when we clone it to get GS next, it's also false. So that's good. One thing I want to check is okay, one thing I want to do let's just double check clone, right? Well, let's do GS next equals GS next. False, because they're different objects, right? Just kind of do that. True, okay, good. So this shows that GS next and GS next are different objects. Let's just do our fancy, what do you call that? Our GS next dot print coins discretized. What? Print coins discretized. What's this 3 mean? One, two, three, four, five, six, 7, 8. This means that we see this line 3 times. And then 0, 0, 0, 1. Right, so that's 3, 3. So this is correct for GS next. The point is, yeah, I get it. So like you see like there's 15 rows, right? You see 1, 2, 3, 4, 5, 6, 7, 8. You're missing 7. 3 minus 1 is 2, so that's 2. 2 minus 1 is 1, that's 3. 2 minus 1 is 1, that's 4. And 4 minus 1 is 3, that's 3. So 4, 5, 6, 7. So that explains like, so if you kind of like have 3 of these, and then 1, 1, like 3, 4, 5, then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there you go. This is a short form. But the point is that if we take this, which we just printed, and now replace next with just next, it gives you the exact same thing, right? 3 of all zeros, same. Then 0, 0, 0, 3 zeros, a 1, 3 zeros, a 1. And that's it. We know everything else is the same. Why? Because the only kind of thing that we touched from GS to GS next was this coin right here, right? From like, yeah. For example, like GS dot. Well, we already did this last time, so yeah. So that's good. Now when we apply it, let's apply the move. And now let us have a little prediction, right? Let's have a little prediction here and see what it predicts, right? Oh, sorry, debug output. So this is what was just printed by the last one, right? Actually, let's not look at this. And what should the output look like? What's the difference after we applied the move and printed it out, right? We applied move 2, right? So now, this coin, right, like you see this coin here, it moves here. So like, what was 1, like 1 and a few zeros, I think like 1 and maybe like 3 zeros or 2 zeros, becomes like 1 and some more zeros. Like this kind of gap increases, right? So let's review it, right? We just printed this out as GS next in line 32. We just printed that out, right? So let's kind of see how it looks like, right? So we skip that. So this is the first coin of the this is the first coin, and that's that one's right there. So like that's this and this, and then we're gonna see that and that soon. A bunch of zeros, and now here, see. 1 and 3 zeros, whereas first after this 2 it would be 1 and 1 0, right? Like you see it's like 0 1 and like 0 1, but now like it's moved 2 squares. So from here, from this like 0 to 1, it's kind of increased to 0 0 0 and then 1, right? So we can see the king coin is moved, right? And then we're gonna make sure that now we're gonna like once we execute this line of the next prev, just GS next print, we're gonna see this transform back into this one. So from 1 0 0 0, it's gonna go 1 0 and end. Boom, right? See that? 1 0. From 1 0, I mean from 1, so it's like 1 0 and like it's like 1 0 0 0 0, right? So we do that, and then the next line, what we're gonna see is this one here is going to drop into like, this one here is going to kind of like become this one. So we're going to have 4 of these zeros in like 0 0 1, right? Boom, right? 4 of these zeros and 0 0 1. Basically undoing, like going from this coin to this coin, like kind of moving back down, right? So we can see that everything looks correct. So printing out these kind of looks, everything checks out. So that is good, right? Nothing wrong there. In fact, this seems like a good point to just kind of commit our changes. Wait, does it change in GameState? What's that again? Ah, yes, crucial. It's nice that our scratch pad actually showed us a bug, like we fixed an error. So get status, get at all, status. Or actually, let me how do I git restore stage or never mind, but I'm gonna kind of commit this like, but we did fix a bug in GameState. Particularly, we had to add this line when we applied the move. That's crucial. Now time to yeah, for testing symmetries, let's actually create a symmetry, right? Or what is it? Let's kind of open that, and let's also open up symmetries.ts or symmetry.ts. And now let's test out symmetries. Symmetries. I should have copied both the lines at once. Okay, so that should be good, right? Then so horizontal is the second one. Let horizontal I'm just kind of getting our horizontal symmetries of 1, right? Because like you see like these, like this is 0, that's 1, 2, and 3, right? So the first index from 0, 1, index 1, 0, 1 gives you like the 1th, gives you flip horizontally from symmetries that we exported, right? No problems there. So we have our symmetry, right? Now let us let's copy that. Let gs next horizontal GameState equals flip horizontally dot like that, right? Just like that. So now what we want to do is like these 3 lines that we did here, let's just kind of copy them. And then what we want to do here is let's just kind of swap gs next with a gs next horizontal. Wait, what? Okay, never mind. Sorry, I just don't know how to use Vim. Okay, whatever. Just a one-off fix. Just like that, right? So now let's let's just kind of print out everything. So the prediction, right? The prediction is these two here, right? These two here that I've highlighted should print out like we want to like kind of see like a flipped version of this and flipped of this, but this one should remain the same because the flippage only applies to that and that, right? So in fact, you know what I'm going to do? I'm going to take these lines right here, and I'm actually going to kind of move them here so that we can like, by doing these two, the first two, like these two right here, will like kind of show you like this and this in some order, and then these two here would show you like the same two but flipped in like same order of going backwards, and then this one and this one should be the exact same because the symmetry only flips like the state and the previous one because of the historic stuff, right? So let's just check that out, right? And that will be our test for horizontal symmetry. Do that. Oh, I was doing code, right? Terminal, give me a terminal, give me a terminal. Wait, where's my terminal view? Where's my terminal? Okay, whatever. Terminal. Okay, is it there? Let's close this one. Yeah, I've never really used VS Code that much. Maybe like I've only used it like 1 or 2 times before what do you call that? Connect 4, because when I was doing an anti-Tetris. Anyways, BumperCoins bot, we did that. Let's look at our sketchpad and let us go to debug console. Let's clear. Well, it cleans itself automatically. But yep, it just kind of okay. Oh yeah, it's no need for this breakpoint anymore. We fixed the issue where we forgot to advance the turn. Play. Okay. Now let's have a look. We have 6 blocks, right? Again, this one we already know about, where like we kind of have 3 of these and 0, 0, 0, 3 zeros and a 1 there. And we have like this line here where it's 1, 0, 0, 0. And then from like this one, everything is the same except 1, 0, right? And then 4 and then that. So those were the first 3 which we already had last time. And now let's moment of truth, right? So before we kind of drum roll and like kind of like do those 3, let's predict how it should look, right? Like what we want to see is something like this for GS next. Let's call it GS N and then H for horizontal. So basically how this would look is just we kind of flip it, right? So the left-hand side, the right-hand side, what is the new left-hand side? The new left-hand side is the old right-hand side. So it should look like this, right? Like these 3, like this kind of shape gets mirrored here. And then kind of like these 2 would kind of like look like this and this, right? But then rather than here, it's a bit higher up in there. So like that's kind of like this, and then these 2 are like that. So we want to see something like this in our like thing, right? So okay, so 1, 2, 3. Now let's advance to next block. So this block right here, right? 3 zeros, that's fine. And then 0, 0, 0, 1, right? So that's 0, 0, 0, 1, because like this one has like the 1 protrudes out a bit, right? Which explains the extra zeros. So like if you look at that, like basically like we look at the first one, that's like 3 zeros, and then 3 zeros, correct. And then all these zeros, 1, 0, 0, 0 is a mirror of what, right? 0, 0, 0. So basically like this line gets reversed, right? From 0, 0, 0, 1, it ends with 1, 0, 0, 0, right? It ends with 1, 0, 0, 0. And then 0, 0, 1 here, kind of, if you go up there, it'll go like 0, like 1, 0, 0 there, right? Like this one reversed, right? Like 1, 0, 0, like 100 or 0, 0, 1, right? So let's like, so these 2, right, are what? These 2 are basically like this and this, right? So from this and this, we get that and that, right? This 1, this 2, that 1, that 2. So that's this one, this two, right? 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 0, 2, sorry, yeah, so like this one is like kind of like we verified these two as flipped, where like this one is 0, 0, 0, 1, and it becomes 1, 0, 0, 0, so that got reversed, right? Like this line reversed is this line right here, right? So that we've established. The next one is this line here, which ends in 1, 0, 0, and that is for what? This coin right here, right? So this coin ending in 1, 0, 0 ends up as that, right? All zeros in 1, 0, 0 become 0, 0, 1, and all zeros, right? So that like we've kind of like double checked that like this one now matches this one, right? Where it's like 0, 0, 1, right? And now we have two more lines of zeros, and then 0, 0, 0, 1, and 1, 0, right? So what this says is the king is a bit extra protruded out, right? The king is a bit extra protruded out from player 2's king is a bit more yeah, we're looking at this line here, is a bit more kind of pushed, and that one is originally what it always was, is 1, 0, right? 1, 0. And I know that's correct. When we mirror it, right, we should see this tiny one and like this long one, right? Like the zeros basically kind of swapping the, yeah. Like 0, 0, 0, 1, and then 1, 0. We have to kind of see that reversed. Which is right here, right? No big deal. Like 0, 1, and then 1, 0, 0. Like 3 zeros at the end. Like 1 leading 0, 3 trailing zeros now becomes it's not highlighted anymore. Now becomes 3 leading zeros. So like 3. So now it's like 3 leading zeros and 1 trailing 0. Whereas like, which is like the inverse of 1 leading 0 and 3 trailing zeros, right? 1 leading 0 and 3 trailing zeros. 1, 2, 3, and then 4, right? So we have now verified we can now apply a check mark to both these two coins. This one and this one, we are verified to be that one and that one, right? Where like this one is untouched, but this one has a bit of more of a gap to it. So we've kind of like verified that. And now there are just two more coins on the same rows. Again, a simple swap between what? Like 2 leading zeros and like 1 trailing 0 becomes 1 leading 0, 2 trailing 0, something like that. Yeah, 2 leading zeros. Oh, 2 leading, oh, sorry, these are actually the same. There's no difference, right? Like we've never touched these coins, so like this padding is same as that, which is 2 and 2. So that's completely fine. It's 2 and 2. So in fact, these coins should be the same because like flipped, like this distance equals that distance. So when you flip them, it's the same. It's a no-op, right? These two coins end up becoming the same, right? Like they'll both be 2 leading and 2 trailing. Oh, maybe it's just, yeah, we know it's going to be the same, right? Two leading zeros, 2 trailing zeros for both cases. So back here, 2 leading zeros, 2 trailing zeros, right? In this line, we have 2 leading and 2 trailing, then 1, 2, 3, 4. And now here again, we have 2 leading zeros and 2 trailing zeros, like 0, 0, 1, 1, 0, 0, right? 0, 0, 1, 1, 0, 0. And that's that, done. So now we have verified that this is correct, right? And now what I want to add, and so now it's time to kind of test this one out, right? Now we want to kind of like test this one out. So let's kind of do that, right? So the main thing is that this object here, like this previous one, like this is kind of like horizontal. When we horizontally do it, its previous should not be this one, right? So in fact, let's actually kind of add a console.log right there, right? Well, let's do console.log of this one dot prev GameState equals gs next, right? And make sure that that is not true because gs next is this one. Like we have to make sure this previous one points to a different object, right? And you know what? And for good measure, let's kind of like have this one's dot prev equal to just gs, right? So now I've saved this. So this one I'm predicting should say false because because should point to cloned GS to a clone. And this one should be true, right? Because like this one, even though we cloned it, like the clones, whatever, should still kind of point to that one, because like we're only kind of touching like that's how the transforms work, right? Like if you have like A and then B, right? And then B, and then we kind of have like C, right? And then we kind of like do a symmetry on C. Well, we're gonna clone C to like, let's kind of have that be like, or like kind of like a cloned and transformed as like that. So like we have like a new object, like a circle means an object, a distinct object. So like C prime is transformed. And then we have to transform like B prime B2, right? So we take B, and we don't want to directly transform B because that would be a destructive operation, right? We're going to first make a clone of B, and then we're going to, and then a clone of B, so C has a back pointer to B, and B has a back pointer to A. In fact, yeah, these arrows, let me just delete them, these forward pointers, like these arrows should be deleted, right? So C has a back pointer to B, and B has a back pointer to A, right? So this is like this is GS, this is GS next, and GS next, right? GS, GSN, GSNN, right? So this one is the flipped version where we cloned it, and then we kind of like we cloned C, and then we kind of flipped it by this thing denotes flipping horizontally the coins. Then we clone B. And by cloning B, that means the back, like right now, after we clone, actually, let's kind of delete everything. Let's delete all this stuff. Right? So let's go back here and kind of like pretend like we're actually computing or getting the symmetry horizontally of C, right? So first thing we do is we clone C, right? So what does that mean? That means that the clone's back pointer still points to B, right? And then we do that. But we also have to clone B too, right? So for that purpose, whatever we did here, we want to like kind of clone B again, because like when we're flipping the coins, we're doing a destructive operation. So like whenever we do destructive operations on game states, like I notice we tend to clone them. So we kind of copy B, and I can draw a perfect circle. This is a perfect circle, don't deny it. And then we kind of copy B here, and we flip it, and then we set this pointer to now point to that. And this one that we cloned, it'll still point to A because we're not like cloning that. We only have 2 historical past states. So so like the lesson is that how many new objects did we create? We created 1 new object and 2 new objects, right? That's how many new objects we created. We created a new game state, which is the flipped version of that. And not only do you have to flip our game state when we're doing the flip, we have to also flip 1 in the past too. And the exact number is given by the number of historic num game states in net.ts. I did this like 2 streams ago, I believe, or in the recent past stream. So this is what I expect, false and true, in these consoles. So let's give it a shot, right? Let's give that a shot. Do that, and let's kind of get rid of our breakpoint here. Oh, I already got rid of the breakpoint. Okay, good. Let's just run it. Do a console, false and false. Oh, I was expecting false and true. I was expecting false and true. So what went wrong? What went wrong? Why is this not true? Let's kind of compare this with this, right? So 4224, 4224, good. And then for the middle ones, and the 4224s are 4 zeros, and then 001, 100, 001, 1, so like it's kind of like everything's kind of like that, right? Everything's kind of like vertical, like this 4 matches that, this matches that, these two match that, and then that, right? So it's like 0, 1, 1, 0, 0, 0, 1. Basically like the initial thing, right? The initial thing. Wait, sorry, wait, what? No, I'm comparing the wrong things. I want to compare this one with that one. 4, 2, 2, 4. 4, 2, 2, 4, and then like 0, 0, like 2, 2, 2 leading trailing, 1 leading trailing, 2 leading trailing. So it's like 1, 2, 1, like the initial, right? 1, 2, 1. So that's correct. You know what? So both of them should work, it says, right? And we already... Okay, time for some debugging, right? Or let's just first kind of step through it like in our thing. So GS next applies move of GS. Okay, you know what? Let's just check that. Console.log gsnext.prev GameState equals GS. Should be true, clearly. Okay, so that's true at least. So we have GS, then GS next was points to GS. Then we apply the move on GS next and like apply move kind of backlinks it. And GS next we apply move kind of backlinks that. So GS next basically will point to GS. And then when we flip the game state of next, then its previous game state is a clone. But then that one, okay, let's put a breakpoint right here, right? And let's kind of like step into transform game state maybe. So GS, so let's kind of step into that. So this, what we're cloning is GS next, right? We cloned it and we set it to the current one. All 6 coins are done. And now what we do is we have a prev game state, which is what? This is the GS next, right? This is GS next that we're working with. And now what we're doing, so this prev game state is for GS just next. So if we look at the coins, or a cur clone game state dot prev state dot print coins discretized, right? So this, what we see right here is for it should be for GS next, right? It's this one's prev, right? So it should look like this, right? Let's check that. The extra 0 here, which shows the boost and shows like only 3 rows of zeros and not 4, whereas like here you have 4 rows of zeros, so that's good. And then let's see the other thing that happened. Well, that's it. Everything else should be standard, right? Yes, like this kind of went from here to here. Like this coin jumped up from that, everything else correct. So right now the prev, like this reference, which I just printed out, looks correct, right? So right now car.prev kind of is referring to GSNext because we have to still clone that, right? So if that exists, which it does, then we kind of take car.prev and we clone it, right? So then this one, so now we have the previous clone game state, and this clone game state now refers to this object right here. That is our prev games, our pre whatever, which I'm just talking about, is this one. We kind of cloned that. But in cloning it, it should still point to the old GS, right? That should still be fine, right? And then we kind of create this new link. We create that link right here, where car game state is still this one, and now its previous one, rather than being here, now gets kind of pointed to this one, so that's fine. And then we of course advance the pointer, right? We advance the car to be the prev. And that should be it, right? Oh, I think it's this one minus one then, right? Or wait, is it? Oh yeah, I see the bug. I see the bug. Okay, yeah, that's the problem. Like, we already did the clone once. So what we have to do then is we have to do it like, yeah, okay, so that's the issue, right? Like, how many clones do we make? Like, how many objects? We have like one object and the other object, right? We don't, like here, like in each of these for loops, in every single one of these for loops, what's happening is we're calling a clone, we're creating an object. We already did the first one, right? Like the amount of like kind of back cloning we have to do is that one minus one. Okay, I think that's the bug, right? So then this one should be number of game states minus one because minus one or wait, hold on. So right now we have cloned, we have cloned, let's undo everything. So we have cloned, we've cloned the GS. So we've cloned it, right? So cloning it just takes that. And then we transform all of these. And then we go here. And we transform all of those. Okay. Okay, I see. I see the issue. Because, like, no, this should be num game states, right? Because in this loop, we're doing transformations, right? So that's actually pretty important, right? We have to, like, how many transforms, like, how many t to transform lambda? How many of these do you have to pass in? How many transforms do you have to make? Well, this one has to transform here, and that one has to transform there. But then the problem is that we end up, like, kind of, like, creating, like, a clone thing, but not transforming it, right? So like it's like a do while loop, right? Like the issue is like after we transform, like yeah, so how do I make this work? Like I could just put a break or a So like what happened is like we transformed this, like we did everything correct, but then we have to do the same thing again, right? And then like we're in here, and then like we kind of like set, like when we set the cur to the prev, then this cur became like now points to this thing right here. And then we do have to kind of copy over all those coins, right? We have to like kind of like make these coins kind of do their work, right? We have to make them all kind of match up. But then when we do the advanced to the prior, then okay, so let's just take it from the top, right? We're calling it on GSNN, right? We're taking it on GSNN. Then we're cloning it, so then that kind of creates this object right here. So then we cloned it, and then we're setting it to be we're just putting a pointer to it called the cur cloned, right? We can do that. And then we do this twice. What do we do twice? We first do the actual flip on it, and then we kind of do some pointer weirdness where some link magic where we look at the previous one, and then we kind of set it for preparation to kind of like put it into a state that we were just in, right? Like we basically do the advancing where what we do is like we look at our previous one that was already there, and then we actually clone it, and then we just do the pointers to make it point to the cloned one. So now in the next loop, what's happening? So now like what's happening is we're kind of working like from here to here. We're now kind of working from here to here, and then we do the transforms, and then we kind of like set that. So we don't want to do the extra, so yeah, like we do want to do the transformations, but then at the very end, we don't want to do any advancing game state of prior, because this advancing actually causes a clone, right? So that's a bit unnecessary. So like if k equals a num, or if k is less than the num of game states -1, and that, because now let's say k is equal to num game states -1, right? Where num game states is 2, so 2 minus 1 is 1. So let's say k equals that, right? Then this thing would be false. So then we break, right? Which means we only do it once for 0. Or we do it 0 and then 1. So we do it for 0, then k is 1, then we like do the second transform where we're transforming these coins to be there. Like we do the transformation. But then rather than kind of copying this and setting the prev to be that, rather than doing that, well, we've already done it twice. So then we don't do any more advancing, because yeah, we've already done k transforms, or num game state number of transforms, right? So there's no need for any more advancing once we've done the transforms, right? K equals to num game states -1. We've finished k transforms. No need to prepare the k plus 1th transform. That is, no need to call k plus 1 clone operations in this function, right? Because we already have like one from the outset, right? So yeah, I think that's like the stuff we need to do. And now let's just kind of compile everything, and let's kind of remove this breakpoint, and let's just run everything. See, false, true, true, right? It was first false, false, true, but now it's false, true, true, right? Well, this one is trivially true, so we can delete that. And now it should just be false, and then it should be true, right? I just want to see false, true with my own eyes. Run and debug. False true. Okay, good. And now let's just kind of visually test all these again. So 1, 2, 3 should be the same as 3, 2, like should be like this, this, this. Basically, we're kind of like making sure that like, if this is like, let's just call this like 1, 2, 3, or sorry. So this first block here, right? What is this? This refers to these coins, right? Does that look correct? Yeah, that looks about right, right? Yeah. So this right here refers to this. So now let's make sure that like we have it mirrored, right? So we have to go like, so this is like GS next. This is GSN, this is GS, and this is that one flipped, right? So you have to verify that these ones kind of match this, right? 1, 4 zeros, then 0, 0, 1. That is correct. Then 4 zeros here, which means that this one's extra protruded, which is kind of how that one was. So like that they match. Then everything else is just pretty straightforward, right? 1, 0, and then 0, 0. So like if you take this and like kind of copy that here, or just kind of like make a note of this file, like these ones right here, like 3, 2, 2, 4, and like kind of like that. Compare that to like 3, 2, 2, 4, and like 3 zeros, then 0, 0, 1, and 1, 0, 0, then 0, 0, 1 here, all zeros. 0, 0, 1 here, all zeros, then 2 rows of zeros, then 0, 1. It's like 1 leading, 3 trailing, now becomes 1 leading, wait, what? Sorry, what am I doing? So 1, so 3, 2, and then 0, it's like 1 leading 0 and 3 trailing zeros after the 3, 2. 1 leading, 3 trailing, 1, comma 3 becomes what? 3, comma 1. 3 leading, 1 trailing. So 1, comma 3 becomes 3, comma 1, where x, comma y means x leading, y trailing, right? Then 2 more zeros, then 2, comma 2 and 4 zeros. 2, comma 2 and 4 zeros. That's correct. X, comma x flipped is x, comma x. So we verified like these coins match these coins again. And then all we have to do is just compare these two. And there's no point comparing that because we've kind of verified that they're the same object, right? This pre is the same thing as that. We have to compare these coins. Let's start off with this one, right? So this one here is 0, 0, 0, 1, right? And everything else 0. And what we want to see is this coin, we expect it to be like, this is a little bit extra, like 3 zeros, and a bit like that. We want to expect it to be like this, right? That's what we want to see. Because this one mirrored should be like this. Basically, like these are kind of like the same. And the only difference now is with this kind of king position, right? Where like this one became that one. So like rather than like being so far here, right? Kind of like that and that. Sorry about that. We just kind of want it to be like just like what? Like this, right? Just like that. Where like these are kind of like the same, like whereas like this distance and this distance kind of match, and like this distance and that distance kind of match, right? So the only difference is between here and here. That's kind of like the idea, because like we only launched like this coin here, like these kind of 4 basically kind of like stay the same even if you flip them, right? That's kind of like the point I'm making. The only difference is like the coin on the left is a bit more towards this midpoint, whereas like, yeah, kind of like from here kind of becomes like that, like, you know, you get the point, right? So basically, okay, fine. So let's kind of like see it, right? So like this, this one, we have 3 rows of zeros, and then 0, 0, 1 in all zeros, right? So now you have to skip by wait, what? So like kind of skip that, then skip this, and we're here, right? So 3 rows of zeros, and then all zeros and 1, 0, 0, 0, right? So that's correct. Like 1 and like 3 zeros, 3 zeros and 1. So this coin maps to this one. That's correct. And then what? We have 0, 0, 1, right? Which should be 1, 0, 0. So like what was like 0, 0, 1, and then 1, 0, 0. So that means like this 1, 0, 0 is 0, 0, 1, And then every single other thing, the remaining 4 coins, every other line should be the same, right? So we have 2 rows of zeros, then like, sorry, we have 2 rows of zeros, 0, 0, 1, 1, 0, 0, 4 rows of zeros. So 2 rows of zeros, so 2 rows of zeros, 0, 0, 1, 1, 0, 0, 4 rows of zeros, right? Let's check. 2 rows of zeros, 0, 0, 1, 1, 0, 0, and 4 rows of zeros. So that seems to be correct, right? So this one here is that one. So this coin here is that check mark. It's like kind of like, it's like, typically we'd have like 4 rows of zeros from the top, but we only have 3, which means this is a bit higher up. And rather than having like 3 trailing, or so it has 3 trailing, rather than having 2 trailing zeros like this one does right here, it's a bit kind of more inward, more medium, more central. So this one right here basically is this coin. So that is done. So that check mark holds, right? Now let's check about this one. So this one here kind of has 4 rows above it, and it's 0, 0, 1, just like that one, right? It's like the similar thing, right? So that's done, and then everything else is the same. So the only kind of difference is like this coin from one here kind of goes here. Like this one here would have originally been here in the original game state, right? In fact, we can actually see that, right? Wait, no, what am I talking about? Wait, where am I? I'm kind of lost. Wait, so 1, 2, 3, 1, 2, right? So like this one here would have been like 1 there originally, right? Like you see this like 1, 0, 0, that's where it would have been, right? Right there. Like 0, 0, 1, then 1, 0, 0. Like 0, 0, 1, 1, 0, 0. But then this one kind of moved on to the like row above it. So like from 4 it becomes 3. That explains that jump in 1, 0, 0. And everything else is the same. In fact, like the stuff we're printing out here, like this thing here, it doesn't really matter, like kind of checking against this one here, because they're literally the same object, right? Like printing, like when you print out, like we're printing out like this thing we're printing, like NNHPP, NNHPP, prev, right? That's the exact same object. So like, yeah, like GS next. In fact, yeah, let's just have another thing where like, let's kind of like verify that they're the same object by doing this thing right here, right? Right? GS next, prev, right? This one's next, prev equals original one, right? Like next, prev. Make sure that we haven't like messed up any of those pointers. So let's just kind of save that, and then let's just run it, or compile it and then run it. So we expect false, true, right? That's kind of like the idea. Debug console, run and debug. False, true. So I think as of now, we have just verified horizontal symmetries. So I think I'm just going to end the stream here, and like the remaining I'll just do next time. Get status, get add all, get commit, fix some bugs in GameState and Symmetry. And in GameState, fix some bugs in GameState, apply move, and fix bugs in GameState, apply move, and Symmetry transform GameState. Where the bug in the apply move was after we applied the move for a certain player's turn, we forgot to flip the whose turn it is. Like if player 1's turn is true after we apply the move, the game state should read GameState.player 2's turn equals true. So player 1's turn should become false. Like there should be a toggle, right? And then Symmetry.transform GameState, which we have to do. In transform GameState, what we did is we had to actually terminate the loop a bit earlier. Like we were doing 1 extra clone, which I mean is probably okay. Like it's okay to clone things, but like we want to like be we don't want to do extra work, right? We only want to like Symmetry should only clone like just 2 objects, right? Like in here, right? We only have like 1 object here, 1 object there, and like that's it. That's all we expect Symmetry to do, right? In fact, when we're doing the Symmetry for B and like C, we're gonna get some overlap of cloning anyway. So like, I mean, maybe we can kind of like store pairs or something, but I mean, I think that's an acceptable hit. So yeah, I think that's all for now. I'll just commit this, get status, and then I'll push it later. So I'm just gonna end it right here. Yeah, it's lunchtime. Oh, battery's almost dead too.